Interesting, isn't it? Novel, even, like a mechanical hummingbird, a 300-mile-an-hour hummingbird. Who needs it? Well, Boeing and Bell, under a federal government contract, are looking into just that. What are the potentialities of the tiltrotor in civil aviation? For 30 years, the airplane industry had been trying to take the best features of turboprop airplanes and combine them with the best features of helicopters. Well, they've done it. The first XV-15s were built back in 1977 and have logged over 800 test hours. The success of the XV-15 development program led the Department of Defense to sponsor further technology development in the V-22 Osprey. The V-22 first flew in early 1989, and it's now in full-scale development. Joining other technological developments of our century, tiltrotor is here. Technical developments to date suggest a commercial tiltrotor may offer solutions to a number of today's aviation problems. But first, we, that is, Boeing and Bell, need to make sure we understand the problem. For example, congestion, airport access, and airspace are all approaching nightmare proportions. New York area airports are suffering from delays amounting to 2,000 hours every day. 100,000 airplanes were delayed at the area's 3 major airports by 15 minutes or more in 1986. But anyone who has ever got into late afternoon traffic heading for Logan or JFK knows the meaning of gridlock, and that traffic hassles are not just in the air or at airports. Tomorrow's New York commuter might use any one of a number of verports scattered about the metropolitan area to get to a business meeting in Washington, D.C. Between 35 and 75 passengers will board with their baggage. Moments before takeoff, a messenger will drop off some small packages as cargo. "45 minutes later, the commuter rotor will be flying over Washington. Ground-bound business colleagues are still sitting in a cab somewhere out on Long Island, staring at the traffic, fuming, losing time and money. A package messenger might be in that same traffic. It has no tail rotor, so it's quiet. Quiet enough to take off and fly over cities without annoying people. That makes the tiltrotor a good neighbor. But you may expect a new technology aircraft with new innovative operational capabilities to challenge the existing air transport infrastructure. New air corridors and verports, for example. Verports would occupy 4 acres instead of thousands. Carriers now competing for slots might see this machine as the aspirin for a lot of headaches. Tiltrotors go their own way, independent of fixed wing patterns, some of which they could replace. So tiltrotors might have the effect of actually increasing existing usable airspace over cities. Major challenges will have to be resolved if a commercial tiltrotor is to operate successfully in your market. Things like all-weather capability, public acceptance, and bottom-line costs and yields. The federal government has asked Boeing and Bell to identify the next steps toward introducing the tiltrotor solution to the air transportation system. To do that, we need your input. As a potential operator, government agency, or user, you are positioned to help us find the answers. The tiltrotor, just an idea, or an idea whose time has come?